Welcome everybody to another How It Works, this time on the mysterious can observe. This is a new observable for CanJS that's kind of like can define map or can map, but this one uses ES6 proxies, which enables it to look and act just like a normal JavaScript array or JavaScript object. It's not yet as powerful as can define, but what it makes up for that is what it makes up for in lack of powerful features, it makes up for in looking just like a normal JavaScript object and behaving that way. So what I'm going to go through today is a little bit of some examples of showing it how it works, at least those in the documentation, but then I'm going to be going through how it's built. And where this was a like some of these other things that I've been showing have been improved how they've been built over years. This is brand new, so it might be a little bit less elegant than some of the other things that I showed in the last two trainings, but at least this will be a good opportunity for everybody to learn about proxies and see their raw power. So let me share my screen and let's begin. And please stop me if there are any questions. And if if Mike, Ryan, Brad don't mind, please monitor Slack in case anybody asks some questions, because I will not be able to see them.
Will do.
All right, so can observe is a package that exports a function that you can pass it a object or an array, and it will return a new, what really a proxy to that object or array that behaves just like, it's just like a normal object, but you can observe through can reflect changes in that property. So here I've got a dog that has no name property, but I can bind to the name property, and then I can later add a name property, and this binding will be fired. And this is something that isn't easily accomplished, at least not with the dot operator in with can define, but it is possible with can observe. So it works nested automatically. So all of the properties in, so here's another observable object I'm creating with a name with a nested first and last properties and a hobbies array. You can use delete and set properties just like you would a normal object at this point, and it works just like a normal object. You can use all of the array methods, and although I haven't tested it yet, which I need to probably soon, you should be able to use any Lodash method, and it should just work on these objects, which is really nice. And they work with can observation and can compute, just like you would expect them to in CanJS. Can observe also comes with a array and an object properties. So I'll show object. The can observe export is a function, but it also exports a, on that function, there is a object property, and you can extend this and make your own observable object types. So here I'm creating a class person, and their getters will be, will have the same behavior that define map getters have, and this will be converted into a compute. And so if the full name property is bound to, I just realized I forgot the pluses right here for some reason. Only if first or last on this person instances will, only if first and last change will full name be recalculated and the events dispatched. I'll give an example of like a little view model here that you could build, and you can use this with can component. So you can now just extend observe object, and instances of this will have your on, off methods, things like that deal with binding, where if you use the normal observe function, they will not be decorated with those functions. It can also be used as a, I think I talked about it here. It can be used as models as well. So if with CanConnect, you wanted a to-do type, and with a method to update the to-do, you can use this like this. Any questions? Because I know I'm going to go into showing how this works. Questions about the functionality? No. One thing is I did mention how they're currently less powerful than define map. So if you wanted to, for instance, this shows like you don't have asynchronous getters. If you have asynchronous getters in 4.0, there's going to be this connected callback, which allows you to, when essentially an instance, when the components element is inserted into the DOM, its view model will have this connected callback method called on. So here I'm doing kind of asynchronous getter behavior where I'm listening to when to-dos promise changes and updating the to-dos list property myself. There's things like that you have to do if you want something to be non-observable. You can't just write or non-serializable or non-enumerable. You can't just write serialized false. Instead, you have to define the property yourself to be enumerable false. So it's not, syntactically, there's not the same level of syntactic shorthands, but there's ways to set up most of the old behaviors of a define map.
Justin, did you say that there's an observe.array as well? I missed that.
There is. So this is just the same thing, but you can extend and make your own array types. So this is, if you have a models, if you wanted a to-do list with active, complete, and different methods on it to interact with your to-dos, you could do this.
Great.
Is there a way to specify what types of items?
No. So there's not. I am thinking about making a way for this because internally there is a function that because everything works nested, like any object that gets added to this array is going to be converted into an observable object. But right now there's not a way to configure what happens. That's something that could be added. For now, CanConnect already would create, if you're using it with CanConnect, create to-do instances and add them to this to-do list. So it's fine with CanConnect, but there is no automatic type coercion. There's no type stuff like there is for define map. You have to do that all yourself. So that's what I'm saying. It's underpowered compared to define map right now, but it works. So that's the important thing. Okay, so let's go talk about how. Let's talk about how it's built. So I'm trying to add everywhere these how it works sections, so people to give an overview of how this functionality is built for every one of these big packages inside CanJS. So look out for those. But before I jump into it, a little bit about proxies, because they're really important to understand. So proxies essentially create almost like a new object based around a target object. So here, let's just say I have a target object and I want to make a proxy to that target object. If I just do this, if I just create a new proxy, pass it the target and pass it no options here, or just empty options, anything I do to the proxy falls through to the target. So if I set proxy foo to bar, then not only, then the target foo will be bar. And also if I read proxy foo, it'll be bar, it'll be whatever target is. And if I were to change target, capital bar, then proxy foo would now be bar. One important thing is that proxies are not equal to their target. A proxy has a different address in memory, so it is not the same thing as a target. But for all intents and purposes at this point, like any change I make to the proxy is going to be reflected to the target. Any change I make to the target is going to be reflected onto the proxy. Now, what proxies do, what's so special about them is that you can implement certain methods that control the behavior of how the proxy interacts with the target. So let's say I wanted to control whenever the dot operator was used to read on the proxy. So this is, I want to control whenever essentially the dot operator is reading, I can implement a get. And this gets called the target and the property. And what I could do is I could just say I'm going to always return the target's property, but to uppercase. And now if I were to read the proxy, so let's say I set the proxy foo to bar, which is essentially, it defaults to just setting foo on the target. So if I don't implement anything here, again, if I remove everything, then it just sends all commands straight to the target. But I can intercept them here and do whatever I want to the target. So now I'm intercepting get. Well, I'm not intercepting set, so this will just set foo to bar on the target. But now I'm going to intercept the get, and it's going to return the uppercase value. So you can add getters, setters, has own key, a whole bunch of things here that control essentially the behavior of these operators on your object. Or things like object has own key, like has own property. You can control all of that kind of stuff through the proxy. You don't even have to provide it a target. You can just provide your own methods that, it just, there won't be you have to provide them all then, because it's just going to try to like operate on null. Typically people will just provide an empty object then.
Well, you're kind of touching on what I was going to ask next was, is there any point when you're using proxies where you want to actually interact with the target object? Like as a matter of practice, I know
we are right here.
I mean, outside of like as a consumer of that object, if you're doing things on the proxy object, adding properties, updating things, and so forth, is there any reason, just as a matter of best practice, that to even keep a reference to the target object?
Possibly. I mean, so like I saw one thing that we could do now is make Chris actually showed me this that Ember does is you can make a proxy that kind of stores that allows you to simulate mutations on an object and then kind of almost like do a transaction where you commit them all at once, but it appears like it's the underlying object. You would still definitely want to reference to that underlying object so you could commit them all at the end.
That seems like something a library author would do, but just a normal day-to-day consumer.
A consumer of the proxy, like what do you mean by consumer? Someone who's using
just a day-to-day programmer, someone who's not writing a library, someone who's not trying to do something crazy advanced. I
don't know why you're using proxy if you're not trying to do something crazy advanced. I mean, they are kind of, I would say, a very advanced. I guess I don't have a use case in mind where your day-to-day programmer is.
Like if we were working on a project and we wanted observable, an observable and reactive view, representing our states. I don't care about all the implementation underneath of proxy. I'm just going to be using this new can observe, and it just seems, I guess, kind of like there's some potential confusion for, you update a property on the proxy, but therefore it didn't go through and touch the target yet. And then you try and reference something on the target and it's not in the state you expected in. I don't know. It just seems like if there's like when you do our proxy equals new proxy, you forget the target that you passed into it and you only interact with the proxy object after that kind of thing is, I guess, what I'm trying to get to.
Yeah, generally that's the practice is you will interact with the target after once you have a proxy for it.
Okay, cool. Sorry, I didn't mean to go on a big segue.
No, yeah, no, it's good. I mean, that's where I would say that the use cases of proxies could be very wide and vast. I mean, in some ways, it's like almost operator overloading. I really, yeah, I don't know. We're using it for this use case. I haven't explored. There's things like I've heard people are doing where this object, your settings object, is actually a proxy itself and can intercept and like dynamically provide a get or set property. I don't even know what you would, why you would ever do that. It's just like super meta for being meta. So yeah, I don't know. I don't know what all the use case of proxies are, but for at least for CanJS, you're right in that typically once your target has gone into the proxy, you should always be referencing the proxy and you should kind of forget about the target.
Okay, cool.
And that's why there is that like that array and object, because you can just create a new observe.object, and then this is just your, this is a proxy, and then there is no kind of target source, right? To accidentally be mutating instead of the proxy. Anyway, so let's go through how it works now with that base understanding of proxies. So essentially there's three functions. There's this make array, or there's make object, make array, and make function that are used to take either an object, array, or function and make it, and essentially return a proxy form of it. So we'll go through those. We'll go through the make object one first, because this is the most important one. So I would say this building can observe the weirdest part of it is that you have these kind of weird implicit, like you have cycle dependencies that kind of have to exist, where like a observable object, when you're building a proxy for an observable object, you might need to build a proxy for an observable function. And when you're building a proxy for an observable function, it might have object properties that point to objects. So I kind of wanted to build all of these things separately. But they all need to kind of be combined at the end. So essentially, really architecturally, there's these three main functions that return proxies, but then there's another function that essentially assembles based on the type of a value. This is that like main can observe function. If it just checks if it's a function, then it's going to call the function that takes functions and produces proxies, or the function that takes arrays and produces proxies, or if it's an object, produce proxies. And then also there's going to be like a cache that any object that we've converted to a proxy, we store that in a weak map, so we can look up the proxy sometime later. So those are the parts that we're going to look at a high level. And just to recap that, there's these three base functions: make object, make array, make function. They take that type specifically and convert it to an observable. And then there's a big make observe function that you can pass it almost anything, and it's going to pick the right function, right base function to get its proxy. And then it's going to store the result in a weak set. So if we see that same object again, let's say there were cycles in your object, or for some reason, we are going to be able to handle that and not duplicate, creating a different proxy for something that we've already seen. And yay, weak sets, you are the best, or weak maps, you are the best thing ever. Because it would be like almost impossible to do. I mean, you couldn't avoid the cycle problems without those and not create memory leaks. Anyways, so let's go through how it works. essentially, here's where I'm building the proxy. And I'm taking that target object and I'm passing it to the proxy. And down below, you'll see the get and set methods. And we'll talk about those in a second. And there's a has own keys, a delete property that we're filling out. And then on our proxy, we actually, because in the debugging tools, you can see this isn't actually a supported behavior on proxies, but it's useful on proxies to be able to see additional information for debugging. So we're going to store this meta object, which is going to contain essentially what we need to do is there's some certain properties on any proxy that we build that are used by the rest of CanJS. These are the symbols that CanReflect is looking for, like on key value. We store all of those things in this meta object under proxy keys. So we'll come to what the meta object does, but this is just like, you almost think of this as like extra information that we want available in all of these methods. So get and set, you know, we need some additional information that's not just on the target. You can't actually put information on the proxy itself because it would necessarily just kind of fall back to being on the target. You have to store things in weird ways in proxies. It's a strange thing. Like you can't actually put the proxy doesn't have values. It always just calls its own get method. So you can't stick stuff somewhere. We need a place to stick things. That's this meta object. So what we do is make it so that the meta object is going to be the this of get, set, own keys, delete property, and things like that. Hopefully it'll make more sense in a minute, but we'll see. Well, I guess we'll see right now what get does. So this is that meta object, which is going to have this proxy keys property. And that's going to be anything that we want to support that's not on the target. We can put keys in this proxy keys on meta. So this is where those symbols are. The can on key value, off key value. I think there's a few more. Those are all mixed into this proxy keys object. They come from can event queue, this mixin that essentially we use the same mixin for define map, can map, everything. These are like the symbols and the behaviors that use can key tree to add observability. So all we really are doing is adding a bunch of symbols that CanReflect is looking for that add observability. And we're making it so that if someone tries to read any of those symbols, we will immediately just return those values, those functions. Does that make sense? That's like step one, right? So this is now we've made it kind of observable. The next thing we need to do is, well, if someone tries to read a symbol, we don't currently try to make symbols observable, so we just skip over that. If you put a symbol on a proxy, it's just going to fall back to the target. Or if you try to read one from the target, it's just going to go to the target. We're not going to mess with those. What we are going to mess with are normal properties that are like, you know, your string-based property names. And we need to have a whole bunch of information on what key is being read, so that we can make sure we're doing the right thing. Now, get is actually called with the target, the key, and the receiver. The receiver is what get was actually called on. That might sound weird at first, but this is an important consideration in all of this. So let's say this proxy was actually was the prototype of some other object. Now, if someone did object.get, or sorry, object.foo or something like that, right? This, and there wasn't an object property, a foo property on this object, but it would eventually work its way up to the getter on the proxy, and the receiver, the target would still be the target, the underlying target object, but the receiver would actually be object. Right? This would actually be the object, because that is what get was actually called on. But the prox, because it's percolating up the proto chain. Hopefully that makes sense. It's kind of a weird thing that you have to deal with proxies. And we try to make CanObserve handle like every single situation. So you can make observables that end up on the proto chain, and it still does the right thing.
And so if you were to have done the same thing on either the target, proxy, or the final object, the receiver would represent whichever one you set foo on. Like if you said target.foo equals bar, then the receiver would be target as well.
Well, it's whatever is here, is whatever as the left of the dot is going to be the receiver.
Yep. Cool.
But if I actually if I just did target dot, it's going to avoid the proxy. If I did target.foo, that doesn't actually even hit the proxy because it's just on the target.
Okay.
Right? If I did proxy.foo, the receiver is going to be I think it's going to be the target in that case. It's going to be the same thing.
Interesting. Okay.
It might be the actually, it might be the proxy, reference to the proxy itself. I think it actually would. Sorry, it would be a reference to the proxy itself. Target is always the target. Basically, it's like who is left of the dot.
Yeah, that's
even though it might walk up the proto chain.
way to describe it.
Yeah. So that's a weird thing you have to. So that's why we do this. Like we call this get key info method here. That I'm not going to go into too much detail about it, but essentially this is just some super function that I wrote that gets as much information about that key and the value at the key as possible. So it's all kind of described over here, but some things like, does the target actually have the key? Was get called on the parent? Well, was the receiver not the proxy? Well, that means it was called on like some parent object, like we just showed. It was called on obj instead of the actual proxy. Does the proto chain down from the target down have the key? Invariants. This is if like you have a sealed object or a property that is non-configurable, like you can't actually change the value. There's special things you need to do there. This is the actual value there. If we went through a getter, and then essentially all the rest of this is actually getting the final value. If it's on the proto key, it's basically we have all this information about the key, the property, where it was read from, and the final value of it. And then once we have that, we can do some things. Now, the first thing that we'll do is, well, as long as the value, we can actually change it, well, what we probably want to do is make it observable, right? So this is, CanObserve is, it's lazy, which is cool. That's in some ways that define map is slightly lazy. Observe is much more lazy, and laziness is good. Don't let your school teachers tell you differently. So if I made a observable here and it had a nested name property and it had that whole like first Justin kind of thing, I'll call this me. We don't at time of creating the proxy, we don't actually go and convert this a proxy, make this a proxy, this internal nested object yet. We do that lazily only if someone actually reads the name property. Then what will happen is we'll see that this is not a proxy, and then we will make a proxy for it. So this will, you can almost think of it as like outcomes of the proxied.
Proxy or observable?
Well, the same thing in this case. When we proxy something, we're making it observable. We're making a proxy that wraps the getter and setter such that it will the setter will fire off events, and the getter will call observation recorder add to kind of alert the universe that an observable property is being read.
Okay, cool.
If people don't know anything about the observation recorder, check the last video, which is talks about can observation and can observation recorder and how that works. So anyways, it's lazy. So this is where we will say, okay, we read the value on the target, go see if we already made something from the store, like this kind of, I talked about the weak map store. Did we already create a value for that object, a proxy version? If we did, return that, because that's what we want to return to the user. Otherwise, create one. That's what this function does. Then the next thing is, should we record an observation? This is that observation recorder add that tells any computes or any can observations that a observable value is being read so that they should bind to it. This is what observation recorder add does that. Now, based on certain situations, you should or should not be doing that. I'm not going to go through those situations. If you're on the prototype and a property below you has or doesn't have a value, like you probably don't want to call observation recorder add. It's really complex. It's weird cases, but most of the time we're going to call observation recorder add to say, hey, you just read this property, CanJS system, bind to it if you need to. We can also, now this is if you have an observable thing on the prototype and then the parent is also observable. So your prototype is observable and the instance is also observable. You might want to call observation add on the instance as well. This handles that. Again, that's a weird circumstance that when you're building inheritance up, that can happen, but that's what takes care of that. It's the same kind of example that we're showing here, where I made this a proxy as well, right? Or wrapped this in a can observe. This is all support. I mean, I would say that Brad set all of this up, and I carried it through. These do behave when you use can observe, man. It really does act like a normal object, and we took care to get a lot of the weird corner cases. Like, okay, you've got a bunch of these proxies sitting on the prototype. How should they all behave? So
give yourself credit for a lot of the refinement, though.
Thank you, Brad. Thank you for setting it up. I like the way we just scratched each other's backs. Okay, so that's the getter. For the most part, a getter, if you the original version of this, like that I built like 4 years ago or 3 years ago, I mean, it was mostly just returning the value on the target, just like looking at the target and returning the key and just calling observation recorder add. And that's all you really need. But all of this other stuff is to handle nesting and proto chains and invariants, if people seal objects, things like that.
Did the handling those edge cases come from trial and error, or are you just looking at a spec or experience? What gave you the idea to cover all those edge cases?
There's definitely no spec on this. It's so new that there's not really a lot of best practices surrounding use of proxy yet. But some of it did come from just trying to meet the needs of what CanJS in general would do, and how to make something like a can observe useful for doing the sorts of view binding that we normally do with, up to now, things like define maps.
Cool. Thanks, Brad.
Yeah, I ended up creating a bunch of like examples that were like, okay, I'm gonna set up inheritance, and what happens? Does it work? No, it doesn't. Okay, what do I need to do? And you kind of discover some of that stuff. Okay, so set. That's the other one I want to go through before we get to functions and arrays. Set, for the most part, is doing the same thing. Like if the receiver is not the proxy, somebody set like on some parent object, well, then we're just going to use this essentially just as object defined property to just set that property on that that object. Because in reality, we don't want to set the value on ourselves. This is standard. This is something that thanks James, if he's watching. He filled me in on a late night on Slack on how to do this right. But if you have this like object here, and let's just say I was doing object create a bunch of times. I just had an object here. Well, if this internal thing was actually like a proxy here, if you did object.foo equals bar, the proxy still can handle that. The proxy still sees that, even though what you really want to set it is on this outermost object, the foo property to bar. You don't want to be setting on this internal thing up the proto chain. So we need to ignore that. Hence this code that's like, if it's not the receiver, just set it directly on whatever your parent was on the receiver. Okay, so now this goes through and reads the key from the target and gets the value that we're actually going to be setting in case if this will actually do the proxy lookup, look up in the store if there's already a proxy observable version for kind of the raw object. And if there is, create that. Now we have that. We call this helper function that's going to actually set the property. And if there's a change on the target, it's going to set the key on the target to the value. And if there is an actual change, it's going to call this function back with the key, the value, the meta information, and did it actually have this property before, and the old value. And this is where we essentially are just going to dispatch an event. So this is using that map bindings dispatch, that kind of mix in that everything inside CanJS uses. It's going to dispatch an event on the proxy of whatever key was being set. Also, it dispatches patches events now, includes the reason log, so we know the reason why it happened for CanQ's debugging. And that is basically get and set. Set value on change doesn't really do anything. It just, I'll show it real quick. I should say Bianca worked on this too a lot, and she definitely helped take it. It's kind of like I worked on a tiny bit, Bianca worked on it, and then Brad worked on it, and then I came back to finish it off. Anywho, all this does is tries to set the property. If there's a property descriptor there, it's going to call the property descriptor, and then if set it on the target, if the value changed, call on changed. Now there is this prevent side effects where we'll see how this is used in a second, but sometimes like the proxies, setters, and getters are going to be called, but we don't want them to do all of the observable stuff. We don't want it to fire events, and we don't want it to call observation recorder add. Observation recorder add. So how do we need to be able to turn all of that stuff off, and we're going to use that in array in one moment. Any questions about this before I go on to array? Okay, array is actually, it's almost identical to, it basically uses almost all of object. This is actually the wrong one, make array. The real difference is for arrays mutation methods, we are going to change all of them ahead of time to produce events, essentially patch events. So and then essentially avoid individual changes on the array. So let me talk about what this means in a second. So if I have an array that I can observe, if you did array.push 1, 2, 3, the push method naively is actually going to do kind of like an array 0. It's going to set that to 1, and an array 1, it's going to set that to 2. Right? Maybe I should have done like A, B, C here. It's going to set to A, it's going to set to B. And now this would normally fire off a bunch of events, right? And that's lame. We don't want to fire off 3 events for this. It's much better to just fire off 1 change. That way, you know, a lot of other things inside CanJS can be more optimal. So this is that like preventing, this is that kind of prevent side effects. What we're going to do is make push essentially turn off triggering events for if just the 0 property of array changed, and instead just fire 1 big like meta event for all of the changes that it's doing. And that is what this kind of relationship here, this kind of little structure where we list all of the mutating methods that arrays have, push, pop, shift, and we provide, and given the array and kind of the arguments to push, we return a essentially the patch change, basically a representation of what's changed. It's like if you push, well, we've pushed in the arguments and we've deleted nothing and we've started at this index. And it's a splice type patch, which all of arrays, these kind of arrays are all splice type patches. So essentially what we're going to do is we make it so that for every, we also can store arrays in that weak set cache, or sorry, we can also store functions in that weak cache. What we're going to go through is for all of arrays mutating methods, we're going to create a different method that's stored in the cache that if like someone reads array.push on an observable, it's actually going to get that special version of push, that version that we created, essentially the proxied version of the push method. But we're not actually proxying it in this case. Anywho, so we're gonna create a method. Essentially, it's gonna increment prevent side effects on that object, so that it doesn't prevent side effects. It's going to call the underlying, the actual push method, but then get the patches that it needs. And as long as like it was able to make side effects before that point, so it's possible that like push could call splice, and you only want to make side effects for the outermost function, which is kind of weird. So that's why we check if we can make side effects in the beginning. And as long as we could make side effects in the beginning, then we're going to dispatch events. So again, to recap what we did here is essentially we're making functions for all of arrays mutation methods that dispatch events for the most part and prevent like all of the index 0, index 1 changes and dispatching. We don't want to dispatch those events. We just want to dispatch kind of 1 event for the whole push. Then we do something similar for all of the rest of arrays methods. So now like we're define map, we would have to go, or define list, we'd have to go in array, we'd have to go to define list prototype and kind of manually add every single array method to it. We don't have to do that anymore. If your browser supports it, like CanObserve will support it. But we're gonna essentially rewrite any like non-mutating functions, something like filter, to prevent side effects from like observation, preventing like, because the filter might have to read array 0, and we don't want to call observation recorder. We don't want to call add R0. We don't want to set up a binding on the 0, 1, 2, 3, 4 property. We just want to set a single binding on arrays can patches event, which fires off anytime the array is mutated at all. So we're essentially just turning off side effects again. We told it to observe this arrays for patches if someone calls filter. And then we make sure that its return value is also going to be observable. So that's what this does. And the rest of it is For the most part, it reuses make objects get. So I kind of try to build this with it's composing. So like it's reusing make object, like what object is doing, its getter and its own keys and its delete property, but it's supplying its own setter. And its setter does the exact same thing, except it just does some extra patches work. So like if it's an enumerable property, like if you set, because again with arrays you can not only set like an R0, you can set that to something, you can set R.foo to something. We have to handle both of these, and in this we want to dispatch a patches event, like a splice happened, a splice patch. For this we want to just say a key was set and fire off those events. So essentially that's what it's doing. It's just checking, hey, there's a number. If it was a number, we're going to do add some additional patches to be dispatched.
It's probably worth pointing out that you can actually change the length of the array under the hood by changing one of the numbered indexes. Like if you set one that was greater than length -1, then length actually is changed, and that even fires an event in the proxy. But because we weren't setting it directly, we might not know when to change it or why. And that and that whole thing has a lot to do with why we have to, like, prevent the setter from doing observation recorder add in certain cases. It's a lot of weird cases. But essentially the length and the numbered indexes have this weird symbiotic relationship in arrays that isn't true for other objects.
Yeah, it's weird. It's weird stuff. Yeah, so it's everything. The weird thing about proxies is that like a method can call back to the proxy's getter or setter, and then and that might in some ways change the length, which could actually just change other properties on an array, because it's even stranger, because there's that symbiotic relationship between the properties and the length of the array and it's all over the place. So we have to just handle all of those cases. But again, this is just figuring out what other mutations happened and then dispatching the events, right? In the end, set dispatches events, add returns the value, and calls observation recorder add. That's all it's doing, is just handling all these special cases. Then the final one is make function. Make function is very similar, again, to how object works. It reuses most of object, because functions have can potentially have observable properties. The big difference for observable or for functions is we are going to trap when the function is called with new, when the proxy is called with new, or the proxy is just called like a normal function, this apply trap. So let me go through what we do. We do add some additional symbols that handle types. Those are all in can event queue has this, there's a type mixin that is used to support when an instance of a type has changed its binding, or when patches happen on an instance of a type. These are all things used by can connect. So we also mix those into any function that you proxy. I guess I didn't really show it, but let me show it real quick. You can create constructor functions like this. The goal is, so if I wanted to make like an animal constructor function, I think I have this, it might be better in the docs. Let me show here. Okay, actually I show it right here. There's a variety of different ways of doing it. Okay. So can observe, you could pass it a normal function and do old school, like, and this will create essentially a constructor function where instances of it are observable, and any properties directly on the function are observable. So here, if I create an animal that takes a name, saves the name, specifies the number of calories, and then increases the number of calories, I can create an animal, and then the calories property is observable, right? So if this got passed to a template, we can observe changes on it. You can also do the same thing by passing it a class as well. So here I'm going to create a normal class animal, but then I'm going to wrap it with observe, and then I get out the actual observable animal constructor function. Now I do make a note of this. Again, this animal that you define in your class is not the same function that gets returned back from the observe function. So the ones created by this proxied function are observable. The ones created by your original constructor function are not observable. Anyways, this is what we want function to support, is this kind of ability. So we do that through this construct. Now, classes don't have, well, let me talk about how we do it first without classes. If you just did it the normal, the old school ES5 way. So you just did this. You called observe on a function that was not defined by classes. If you define a function this way, this animal's prototype is, you can set it, but we can't actually change the prototype of a class defined this way. Because when you define a class this way, the prototype property it's non-configurable, non-writable. Okay, so what make function does is it's just going to, on the prototype, which we made observable in this case. So not only our instance is going to be observable, the actual prototype object of the function is going to be observable as well. So if you suddenly like added something to the prototype later, well, you could actually detect that. Like CanJS could observe on that as well, which is crazy to me, but it works. So we're going to create essentially an object that inherits from the function's prototype. Then we're going to make that object observable by calling essentially the observe function. We're going to prevent side effects while we run the target function. So we're going to run the target function on that instance. We don't want any events to be dispatched because it's almost certainly like nobody could be bound to it anyways. So don't prevent side effects. And then we're going to return that instance unless their target function returned some kind of truthy object, or something truthy. With classes, well, we need to create an instance. The only way to do that with unlimited arguments is using actual ES6 reflect. So then we use that to create an instance, and then we're going to basically make that instance observable. In this case, if you're using classes, your prototype, if you add or remove properties to the prototype, those are not observable. Only the instance is observable. So that's really the core. The only other thing that I'm going to brief, any questions there?
Yeah, real quick, that last thing you just said. So if you're trying to observe a class instance, you can't, if you extend the prototype later,
Yeah.
those are not seen?
Yeah, those are not seen. So like, let's take this, and you can't really do it with classes like nicely anyways, but let's just say I had an animal, and then someone, like I had in my template for some reason, I had an instance of animal, and I had it's like, I don't know, like, what's the property of an animal, like has eyes or something. And let's say, now if I did animal, if I had that animal like in my view model or something that I did has eyes is true, well, that's going to work. It's going to work fine. But if I did animal.prototype that has eyes is true, that would not work with classes defined like this.
But if you just pass a function, it does work, like just a constructor
Yes.
function.
And that is because you cannot change, because what I really want to be able to do is write animal.prototype equals observe animal.prototype. You can't do that. When you define a class like this, the prototype is non-configurable, non-enumerable, or non-configurable, non-writable.
Interesting.
Yeah, which is annoying. I don't know why they do stuff like that, because it's like, I don't know, give me the power. Like, if I'm gonna go messing around with prototypes manually, don't you know, I know what I'm doing. I don't know. I think, you know, so they give you all the syntactic, you know, shorthand with class, which is nice, but they really do lock down what you can do with it, which kind of stinks. So anyways, that's why, you know, I think this is a very small corner case. I really don't think many people, I mean, obviously this doesn't work with define map or anything else in CanJS right now. But I guess I would say it's nice that if anybody ever did need that kind of extensive ability to extend the prototype dynamically and have everything respond to it, well, then just use old school constructor functions and it will work for you.
Cool.
This is something we can, you know, really just state as best practices. I mean, I feel like personally, it is best practice to always define stuff on your prototypes immediately after defining them, if at all possible. Of course, if you have like a hook or plugin system, that does complicate things, but you should always endeavor to set that up before you ever try to like render it into views.
For sure.
Yeah, certainly. It's news to me. I use the new class syntax a lot, and it's news to me that I couldn't come down and write animal.prototype later, that I couldn't mutate the prototype.
Yeah, you can't change it to something else. Yeah.
And yeah, that's just...
You can mutate the prototype, but you can't change what the prototype points to.
Okay.
But we need it to have a proxy there, so it doesn't help. We need to have it point at a different thing. So that's why it is that way. So the final thing that I want to talk about real quick, because this is some of the more weird stuff that it does, is I mentioned how object has makes these things backed by an observable, so that full name, if you made an instance of person and you did person.fullname, 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 and if you had bound to it, it's only going to evaluate the full name once until one of its dependencies have changed. Right? This shouldn't be surprising for anybody who's used I don't know if I went into more detail about it somewhere else. This should not be, this is just like how define map works, right? And how getters in the can map define plugin work, right? One of CanJS's nice performance features. Okay, so the way I made it work this time was a little bit different, and I'm not sure if it was better or worse, but it's different, and I wanted to talk about it. So the way that I made it work, I think I do talk about it in the bottom of how it works here. Is I created a memoize function that overwrites, that can overwrite a defined getter to use an observation. And I'll show what that looks like in the test for it. I want to be done in like 3 more minutes because I want to go over an hour here. So what I want to do is make this memoize getter function where here's just some normal object, and I want to say, hey, your full name. I want, if anybody then does me.fullname, it's going to hit an observation inside of here. And we can get that observation and its data with this function that it returns for a particular instance. Because this is somewhat the problem, is like this getter and this function is a static thing, right? There's one of it for all instances of this type. But we need to create a new observation for each individual instance. So that can be kind of tricky. So let's talk about the way that I do it, and please stop and ask questions, because this is the the funkiest thing probably going on in this at this point. This memoize function, what it does is you pass it your type, your property, and the definition. And it's going to make a weak map that essentially for an observation can give you, sorry, for an instance of type, give you the observation for it. And what it does is it overwrites the getter for that property to get that observation for the instance. So because the getter was called, but this is going to be, a unique instance. We're going to get the instance, then get the observation for it. And then we're going to use that observation to call observation get. We're going to do some additional stuff here that just makes sure that we're like, calling observation recorder add to make sure that we try to, in the future, bind to this property. And also we can kind of proactively bind to the observation so it's bound, so it's not going to have to be computed twice. All of this stuff you can pretty much ignore. Essentially what we're just doing is getting an observation for the instance for this getter and then returning the value of the observation. And then what we do in the rest of CanJS for like an object here, well, let me try to explain this the best that I can. Basically what we do is we make it so on the prototype, all of those like handlers that can give you your observations are on the prototype. We can get that function to get our observation. If someone calls like add event listener, like someone tries to bind to that full name property, if someone tries to bind to the full name property, we're going to say, hey, get us that observation, and we want to make sure that observation is bound to for the unique instance. So I don't know, it's this really weird way of doing it. I was kind of inspired by what Austin's memoizer did, where essentially what I'm trying to do is make something that can memoize getters into a function. But the problem is the instances can change. So I'm essentially using a weak map to like know the observation, like dynamically generate an observation. An observation for an instance that we haven't seen before. Does that make sense? It's really odd, but I figured I'd give it a try. What I've been thinking about. Well, any questions there before I go on and make things more confusing? No, probably lost. That's okay. It's crazy. Think about it. Like one thing that I've been thinking about is, let's say what I really want to support in the future is, let's say you had a function that was used in a template, right? You had something like do something cool, and it took like, value 1, value 2. All right. Now, and let's say there was, for some reason, there could be multiple of these. CanJS right now is going to build an observation independently for each one of these. It would be really cool if on your type, you could have your do something cool. And it could automatically, for the same arguments here, essentially build an observation that it's going to give the cached value for both of these. It's not going to have to look up. It's not going to have to rerun the function here. It's going to be able to, based on what your this is, value 1 and value 2, it's going to give you your cached value back. So the second time someone called the same thing, it's just going to give you your cached value back. It's not going to have to re-execute. And then if any of the value 1 or value 2 changed, well, then it would it would re-execute just once, and then both of these would be notified and get their observable value. So one thing I've been thinking about is like I want a generic like memoize function, which could just do this in kind of like future versions of for you know, animal would instead look like that's animal extends object observe object, but you could have these kind of plugins that would decorators that would just add memoization stuff for faster performance. I don't know if that makes sense, but I think it that was the idea, was to be like, okay, well, what I'm going to do is I'm going to rewrite this function to call an observation internally. And it's going to use weak maps to like kind of know if I've gotten the same arguments passed or not. So I was I was building it with that in mind and going through kind of like some of the hurdles that a larger thing would have to encounter, but in kind of a smaller use case where there are no arguments, the only argument that I have to memoize on is really the this. So that is it. Any other questions about how this works? Hopefully I gave somewhat of a rough.
No, you introduced something here at the end, the decorator, and I was not going to ask this question, but since you kind of brought them in at the end here, why have you thought about being able to just decorate class animal instead of extending observe.object? You see what I'm saying? Like,
yes, the
and
the reason why I did it this way because like decorators aren't in browsers right now.
Mm-hmm.
Like there's nothing that officially supports it, and I wanted something where like I could open up a JS bin and
do it, yeah,
and just do it. But it's not hard to just have. I mean, you could just. I mean, decorators are just functions, right? So like you could just call observe.
Yeah, and this is mostly just I think it's mobx that just kind of has it this way, where you observe a class and then you can, I think, observe individual methods in there, or decorate different methods and properties within there.
Yeah.
Just as a matter of convention for what other people are doing.
Yeah, no, I think that's why I think decorators are great, and I would really love to see an ecosystem of decorators built around this. So instead of like I've thought about like for asynchronous getters, we should have a decorator that's just like async, and then you just write some like to-do list, and it takes a resolve, and then it's just going to see this function, and then you can just do like this dot to-do list. To-do's promise, then resolve. This is how asynchronous getters will be done.
Oh, that's cool.
I don't know. Like I haven't. So the goal for this was to like create a very solid core that just works. And the only reason why there's that extends is because I just wanted something that works like in JS without having to set up.
Yeah.
And the other reason is that these animals now, when you do new animal, it does have some additional methods on it that are really useful, like on and off. So you don't have to go through can reflect to listen if you want. The normal to make it so it's clear, the normal observe that you have to go through can reflect. The object that you get back, if you want to listen to, you have to use can reflect. There is no other method. There's if you want to listen to its foo property changing, you have to do this, right? But if you create an instance of observe object, or you have something that extends from it, well, then you have like you can just do on foo. And it felt like kind of annoying to make people use can reflect for everything. It's just nice when I was like making demos and things like that. Like, okay, well, sometimes it's nice just to show a dot on. dot listens to and things like that. Those are all there.
Two things to add here. I just want to jump in for a moment. Decorators are currently in draft state in ECMAScript proposals. So once it actually gets past that, we can definitely start looking at getting support for it into this. It would never really be like the only way to do this, but doing like an observed decorator would be a cool thing to do. And with regard to these functions that come out of observed.object, if you don't have that, you could, if you wanted to, call the symbol functions directly, but we never, ever, ever recommend doing that.
Yeah. So
Cool.
yeah, I mean, I think decorators. My hope is that decorators can be built around this, right? Now the real question is, especially since Ryan, you're unfortunately the only person that's left, is do you feel like you understand how this works a little bit?
Yes, I do, and I really like it. I know you've been waiting on proxies to land for a while, and yeah, this is really cool to kind of see this all come to life finally.
Yeah, and I think like for like React View Model and stuff like that, I think it'll be really useful in those scenarios as well, because it looks just like a normal object. Yeah,
and we just ran into that on our project. It's a convention I'm sure you've seen in views, React views, that you map over an array and return your render, and define lists return an instance. They have a special case just for maps where they return a new defined list, and React was seeing that as not an array of things. It was wanting keys on everything in a way that it doesn't if you just return a normal array kind of thing. And so it was just seeing a defined list as something that wasn't quite an array in React's opinion. I don't know what underneath the hood it was, but anyhow.
So one maybe pitfall then that we'll have to. It was currently I didn't make it actual arrays. It inherits from array, but the array is array check fails right now. Okay. Not on when you not when you just use observe and pass an array. That's still array is array. But if you extend observe dot array, those are not arrays, because mostly out of laziness, because there was a bunch of parts in can reflect that like we kind of have to create a new can reflection that understands it. Like right now, there's a lot of stuff in CanJS that's like if it's an array, it's not observable. We make that assumption. Because we assume it's like a base type and a built-in type. That's not something that we can change. It just, I didn't want to go through all the work to make that also work because it didn't seem like it mattered.
Yeah,
if it does matter, then that's something we can fix like post-release. I'm not sure if like, I'd be curious if like it does matter for.
Yeah.
Everything else matches an array perfectly. It's just array.isArray will return false.
Have you filed an epic for that for 4.0?
No, because I was kind of waiting to see if like it actually mattered before. Like, I mean, it's something to do, but I just like I don't want to put effort into it unless like I knew it was actually going to cause problems. So I just don't know if, even in your case, if it's necessarily going to cause problems.
And I'm now Adam's kind of pinging me on the side. He helped me kind of debug this problem, and it wasn't the fact that defined lists weren't an array. It was the fact that as we're returning VDOM objects from that iteration, they're getting wrapped as a defined map.
Oh, okay. Yeah, I don't think this would. Yeah.
Oh, okay.
Yeah, sorry, and thank you, Adam, for hitting me up on the side about that.
It's because map returns. Yeah, it's because map returns instances of defined list, and unit is just like a plain array. Now that's an interesting thing, because like that's why we built it the way we did, is because the low-level utilities, those 3 functions, you can use to do whatever you want, really. And species and things like that, like, you know, you might, I didn't set the species symbol on our array, so I'm not actually sure what it will return, but it would be relatively easy for you to extend and then set the species symbol. If you know what I'm talking about, it's the species symbol that controls like native arrays map functionality, controls what type should actually be returned.
Okay.
And I
I
think if
think
you
that
needed
gets
to be,
set by default when you subclass. You know, so symbol.species is always going to point back to the original constructor, unless you otherwise specify.
But I think what you would want to do is like you could set species yourself when extending observe array. I think. So that's why it's like it's gonna be kind of like the great unknown for this project. That's why we're not for 4.0. We were thinking hard about like, do we just make this the default for 4.0 because it's a little bit more simple, it's closer to like the hardware, but because it's so like still the great unknown, I felt, you know, we decided to like wait until kind of like a 5.0 before we just like, here's the proxy observable system. It's what everybody should use. You know, because at least with CanJS 3.0, we had a version of can define out for a bit in usable against 2.3 before 4.0 came out, or before 3.0 came out. So anyways, thanks so much for sticking around for 1 hour and 20 minutes. Hopefully people learned something, saw how proxies can be very useful and make these powerful powerful behaviors. If there's things that people want to learn about going forward, how some other internals work of CanJS, please let me know. I think the next things might be some more of on the view layer on stash and parsers and how the scope works and things like that. Let us know. Please like and subscribe. And until then, see you all later.